Today, we are pulling back the curtain on artificial intelligence. We're going to get into the nuts and bolts, the actual process that takes a mountain of raw data and turns it into the smart, snappy decisions that power the apps you use every single day.
So think about this for a second. Have you ever been listening to your favorite music app and it just knows the perfect next song to play? Or you're browsing online and it shows you that one thing you were just thinking about? It almost feels like it's reading your mind, right? Kind of creepy, kind of cool. Well, I'm going to let you in on the secret. It's not magic. Not at all. Behind every single one of those smart recommendations, there's a very clear, very repeatable process. It's like a blueprint. And that's exactly what we're going to walk through together.
Okay, so here's our game plan. First, we're going to cut through all the hype. Then, we'll look at the actual blueprint for an AI pipeline. After that, we'll go on a step-by-step journey to see how it's built, see it in action with a real-world example, and by the end, you'll see exactly why AI is a process, not magic.
All right, let's kick things off. It's time to go beyond all the buzzwords and look at the real engineering that makes AI actually work. So the heart of it all is something called the AI pipeline. Honestly, the best way to think about it is like a factory assembly line. You've got all this raw, messy data that goes in one end. It goes through a whole series of structured steps, and a smart, functional AI system comes out the other. It's the methodical process that turns raw information into real-world intelligence. But why? Why is having a structured pipeline so important? I mean, why can't you just dump a ton of data into a computer and hope for the best? Well, as you're about to see, that's pretty much a recipe for disaster.
And this slide right here, it just lays it all out. It's the difference between chaos and order. Without a pipeline, you're just living in chaos. You've got messy data, which leads to inaccurate models, which gives you totally inconsistent results. Your systems are going to fail all the time. But with a pipeline, you bring in order. You get clean, reliable data that leads to high accuracy models, consistent, repeatable results, and systems that you can actually scale up and automate. You know, it's the difference between a messy garage experiment and professional-grade engineering.
All right, so let's get our hands dirty and break down this entire pipeline. Now, there are a bunch of individual steps, but we can group them into 3 main phases to make it way easier to wrap our heads around. Phase 1 is all about building the foundation. It's all about the data. We have to start by asking the most important question: what problem are we actually trying to solve? Then we go out and gather the raw materials, the data itself. But raw data is always messy, so the next critical step is cleaning it all up. And finally, we get to explore that clean data to really see what we're working with. If this foundation is shaky, the whole thing falls apart. And this really gets to the golden rule of all AI: garbage in, garbage out. It's that simple. You can have all the data in the world, but if it's bad data, your AI is going to be bad too. Quality, clean, relevant data, that is the fuel that powers any smart system. Okay, let's move on to phase 2, the build. This is where we take our great data and start to actually create the model. It starts with something called feature engineering, which sounds complicated, but it just means we're picking out the most important pieces of data for the model to pay attention to. Then we choose the right tool, the right algorithm for the job, and then comes the magic moment: model training. This right here is the moment of transformation. This is where the algorithm just churns through all that beautiful, clean data and starts to learn the patterns inside it. This is where abstract numbers and text are converted into actual functional intelligence. It's literally the learning part of machine learning. And that brings us to our final phase, the launch. Look, just because a model is trained, that doesn't mean it's ready for prime time. First, we have to evaluate it. We test how well it performs on brand new data it's never seen before. Then, we tune it and optimize it to squeeze out every last bit of accuracy. Once it passes all our tests, we deploy it. We set it loose in the real world. But wait, it doesn't end there. We have to constantly monitor and maintain it because the world changes and our model has to change with it. Okay, that was a lot of theory. I get it. So let's make this all super concrete with an example you use every single day: a simple spam filter. So let's run this through our pipeline. Step 1, the goal is simple: identify spam. Step 2, we collect our data. tons of emails, some are spam, some are not. Step 3, we clean up all that email text and train our model to spot the patterns. Weird links, urgent language, all that stuff. Step 4, we evaluate its accuracy on new emails. If it does a good job, step 5, we deploy it into our email system. But of course, the job isn't done. Spammers get smarter. So step 6 is to constantly monitor for new spam tricks and update our model. You see, it's a continuous cycle, and every single phase of that pipeline is absolutely essential.
And that brings us right to our final and honestly, the most important takeaway from all of this. So as we've seen, AI isn't some kind of mystical black box. The AI pipeline is really an engineering discipline. It's a structured, repeatable, and scalable framework that lets people build powerful, intelligent systems, not just as a one-off, but reliably over and over again.
If you remember just one thing today, let it be this. AI is not magic. It's a process, a deliberate, step-by-step, understandable process. And understanding that process is incredibly empowering. It takes AI from being this big, mysterious thing and turns it into a tool, a really powerful tool that you now understand the blueprint for. So, I'll leave you with this question. Now that you know the blueprint, what would you build?